Hello there, virtual machining fans. This is your old machine shop instructor Ed down here in sunny Sarasota, Florida, just south of Tampa Bay. I have a Tampa Bay Rays hat on. This is um, in the transition year when you're going from the Devil Rays to the Tampa Bay Rays. So anyway, you may notice my Ramon shirt. Big fan of Ramones. Seen them many times. Actually got a nice autographed picture, cover. Ramones. Got some other pictures up here. I'm also a drummer. Got some Maki Ramone drumsticks right here. I'll do some drumming later. But anyway, we're here to talk about machining. This is Mastercam Home Learning Edition 2020. This is I previously have done this and have a video before. I did the CAD, I did the CAM, and I was trying to do better simulation actually. So I brought in a vise. This is the actual Kurt 688 vise that we use in our school, D688. Took me a little while to kind of figure it out how to get the stock in the right place and the part in the right place, because I wanted to be able to do full simulation and talk about things you want to look out for. And actually, in these simulations, you can really talk about what you're trying to do. And this is first operation, which is, you can see that the red material is the stock, right? And we're just having a device to hold it in there. And we throw it in the mill. We want to line up that jaw with the x-axis. That's pretty typical in a vertical mill. And in this case, the big transition from manual machining to CNC machining was the manual machine guys used to machine the whole outside and then work on the features. I forget what method, this is actually a term for this, but we're using oversized material and we're cutting everything that we can and holding on to the bottom. So that is represented by this shaded material right here. Okay, so in Mastercam you set up those parameters right here, and you could put solid or wire frame just for, it's only for reference and for simulation. So on this one I use bounding box or all entities to kind of get a rough idea of what size stock is, and I put some oversized material in here, and I wanted it to be something you could buy, in bar stock, 2" by 1", and that aligns with all the Titan projects, most of them. And 4.1 would represent how much we're cutting off on a saw. And we shifted the x-axis. We're using this upper left corner. You can actually move it to any corner you want. Using the upper left corner, and we're shifting it by 50, 50, and 20. And that would align with Titan setup sheets. So that let's go back to this one. If you go back to the original, we're programmed off the model, or the solid model, and you're going to find this outside line with edge finder or probe, and you're going to have to shift it in by 50 thousandths. But that's all on the setup sheet. However you program your parts in the future, you may do it differently. Some people program it so that you just do it off the material and with no shifting. So that really only applies on first operation. When you get in the second operation, you have to be lined up with the finished product, or you cannot be that accurate. Okay, so I got the vise in here. I got it all set up, and I was going to do some simulations. So up in here we have backplot, verify, and simulate. And I was actually trying to run this machine simulation over here because I was playing around with some 5-axis machining, and I don't have a 5-axis machine, but I want to learn, and you don't need a machine to learn it. So, but backplot is like a quick simulation right up here, and there's a little press play button, speed button right here. And right now I only see one green stripe, which tells me I only have one folder clicked. So if I click all these, I get all operations. Okay, let's try that back plot, which is also up here. Hit back plot, and then you see your face mill right there, right. I hit play, we start cutting away there, so we can look at it. So this is like a quick way of looking at is it cutting in the right place and stuff. And the yellow lines represent rapid movements. You know, looks pretty good to me. You know, this is pretty much, we used to do it with just the sketchings of wireframe with no solid in the old days. Now with solid models, you have a better representation of what it's supposed to look like. Only we're still, is this a good setup? It looks like it's good. So let's go to verification. Now verification, it'll open up a separate window. I'll bring it over in the picture here. And I have stock tool, doesn't say fixture, it says fixtures, I don't see it though, but anyway, we hit the play button, and I'm going to put on a thing called color loop, and it actually will be colors of how long each operation takes, and they'll all have their own color. So, all right, I have this set up. Let me turn off some of these stop conditions. Okay. I'm going to rewind this, hit play, let it cut, right? You can see the wireframe boundaries, you can kind of get an idea. That was kind of fast, so let me rewind this. And let's put the stock off. And I'm going to slow this down, slow. Play again, okay. That's still pretty fast, okay. All right, so you can see, you can really see much better how the cutting goes versus the quick verify method. You can actually see it's cutting. Okay, looks pretty good. You can see down here the extra material, and when we flip it over, we're going to be machining that off and chamfering it on this particular operation. Some operations may need more work. Let's do a machine simulation. In this one, you actually have to pick a machine. We picked this 3-axis VMC. I originally had this 5-axis in there for my other learning. So I picked this 3-axis VMC, cut a comp in control, and the fixtures, and let me see, I gotta set some of this stuff up. Fixtures are gonna be, I should have combined all these levels. Bing, bing, bing. Oh, you know what? I could have done it an easier way, but I'm almost done. Done, okay. And what else do we want to have on here? Let's see all the settings. Data, simulation, simulate. Oh yeah, let me back this out a little bit, hit fit. All right, there we go. That's a whole machine right there with the vise and everything. And I'm going to turn on stop conditions. I'm going to do it for every operation, in collision. I want to collision detection. I want to see if this actually works or not. All right, so if I look way back here, this is a 3-axis mill, pretty typical, like a Haas VF2, without the covers on it. You know, obviously with the sheet metal, you couldn't see much, but this would be your Z-axis that goes up and down, the table goes left and right and in and out. All right, we hit the play button, and there it goes. And we have it do pause due to following stop conditions because it was operation change. Okay, next operation would be this one. Can't really see it that much. Let's get an up close view here. You notice that in reality, when you're watching CAD CAM, you're really watching the tool wiggle around and the part stays still. But this is actually what's really happening, is this table's moving back and forth. All right, let's go to next operation. Ooh, that turned red. says right here, a collision occurred. Oh crap, I thought I had everything right. What the heck is going on there? That end mill looks too low. It looks like it's colliding with the fixture, the vise. This is something you want to be aware of because we're running pretty close here. I can see the previous cuts were just above there, and this one is too low. It's either settings wrong or something. But this is what you worry about because these are the hard jaws that come with the curved vise. This is the actual same model. We prefer not to use the hard jaws. We use either steel or aluminum jaws that we make, and we cut a little step in there, like 200 thousandths deep by 200 thousandths wide. So it's like having built-in parallels, but it's like a known distance. So in this particular case, the material is 1 inch tall. We're cutting 750 or 760 plus 20 off the top, so that's like 780. So that leaves about 220 left. If we cut this 200 deep, we'll be like 200 before we hit, which should be enough room. You want to be able to make sure you got enough to hold on to and cut around the whole thing. With parallels, that could be daunting because the parallels are always like you're either not holding it by enough or you're holding it too deep, and something like this will happen. So, all right, let's go look at the numbers here. I think it came, I should have probably checked, but I think it was in the contouring. It wasn't doing the floor. Surface high speed OptiRough was the roughing and facing, and then it did contour outside. Let me take a look at that setting, and let me zoom back up here. Okay, so if I turn this one on, and I'm like, this is just the tool path for that, and yep, it is too low. Let's look at the parameters here. Tool path, change geometry. This is what we're picking, which is right here. You can see right there the green. This means stay to the outside, and that means go in this direction. All right, that looks, the chain looks correct. It's above the fixture. Okay. We got the 3/8 tool, cut parameters, wear compensation, which is going to give you your G41 cutter comp, and stock to leave on the floors, and nothing. We have no depth cuts. Lead in and out looks good. Breakthrough, ooh. Oh, we're adding 10 thousandths. That shouldn't do it. All right, multi-pass is for multiple outside cuts. Linking parameters. We got all this in there. Oh, this one right here. So incremental means incremental to whatever selection you made. And the selection we made was that boundary. So this is adding another 100 thousandths to it. So one way of fixing that is to delete this and pick, if you actually click on this, it'll actually bring you back to the model again. And you can reselect the boundary, which is right there. Yeah, right there. And we don't add anything to it. And I think associative works the same way. The other way you can do it is absolute and put in a hard number. Let's just try that one though. All right, blue is applying and green means I'm done. Done. And red X means you need to regenerate the code. So I gotta regenerate the code. And I'm going to take a look here. I'm really zoomed up here. Let me zoom out here. And I think it's above. Oh, I think it's fixed now. I'm going to hit the fit command. I'm going to hit the isometric. Okay, let's go back to the full Monty of simulation. And I'm going to zoom in on this area again. Okay, let's hit the play button. There we go. Cuts the top. Ooh, it should be over here. Forgot that table's gonna move. All right, cut them inside. Table wiggling around, yep. It's kind of impressive that a CNC machine, all this heavy stuff is controlled by motors and very fast. Oh, there it is. That would have been right after this cut here. That's when we had the problem. And now it makes it. It made it just fine. See, it's close. But close is only counts in atomic bombs and hand grenades. So, okay, here we go. And apparently, let's see, that was the floor. We did the floor, and we're gonna do that wall, and then chamfering, and and more chamfering. Oh, I got the wireframe. That's why it's not looking. That's like the original build. And there you go. And then drill the holes. You can see right there, they're going up and down and going up and down. So let's go back a couple operations here. You watch it from out here now. This is what's really going on with the machine. The roughing is the longest part of the program, but right here is total time, 5 minutes, just over 5. Next operation, next operation. Of course, it doesn't show tool changes because. And then drilling, zoom up again, and then tapping. Done. Okay. I think that's a real good close as you're going to get without machining the actual part to know that your program is going to work correctly and without crashing into stuff. Of course, setup is critical, and how you set your coordinates up. You know, if you're probing or edge finding, if you're doing some math, shifts and stuff like that, you got to take that in consideration. At our school, we run it we put it in the graphics in the control, run it through there once, make sure we get no alarms or weird stuff. We'll shift it 2 inches up in the air, run it up in the air, just to get a visual view of what we think it's going to do, and then we'll take the 2 inches away and we'll just let it eat metal. We'll single block down every tool just to verify that it looks like the heights are correct, or the distance to go numbers are correct. So we have very good success doing that. Okay, so this is your CNC instructor again, online CNC instructor. Just signing off, and do some more programming and CAD/CAM work. This is very good time right now for doing that. Thank you.